Tonight, you'll open a freezer, hear that little plastic drawer complain, and drop ice into a drink without thinking. In ancient Iran, someone could serve a cold drink while the desert outside was hot enough to make the horizon wobble. No electricity, no compressor, not even a suspiciously long extension cord. So how did humans make ice in the desert? And here's the part that should stop you. How did they keep winter alive until summer? The answer looks like a giant mud brick beehive. It's called a Yakhchāl, a Persian word that means ice pit, which is unusually honest branding. You ask what the building does, and the building says, there's ice in a pit. But here's the first twist. The dome is only the part you can see. Beneath it is a deep storage chamber sunk into the earth, where the temperature changes much more slowly than it does on the surface. While the desert spends all day being dramatic, the ground remains comparatively calm. These structures were more than impressive sheds. Encyclopedia Iranica traces simple insulated ice pits in Iran to the 1st millennium BCE, possibly earlier. The famous standing domes are often much younger, but the basic idea is ancient. Put cold below ground, block the sun, and make heat work very hard to get inside. That's the shell. Where did the water come from? Often through a qanat. These were gently sloping underground channels that moved groundwater across long distances without pumps. Because the channel stayed underground, sunlight couldn't cook the water, and dry air couldn't steal as much of it through evaporation. Before you could make desert ice, you had to smuggle water through the desert first. But here's the thing. The water usually didn't freeze inside the pretty dome. Workers guided it into a long, shallow basin outside, called a Yakhband. According to Encyclopedia Iranica, the layer might be only 5 to 10 centimeters deep. Thin water loses heat faster than a deep pool. It was an enormous ice tray, except every cube was one inconvenient rectangle. Beside the basin stood a tall wall, commonly on its southern side. In winter, that wall blocked the low sun from reaching the water. Some walls extended east and west to stretch the hours of shade. This wasn't decoration. It was sunscreen for a pond. Then, the workers waited for a cold, clear winter night. And that word matters. Winter. The internet often tells this story as though ancient engineers poured water outside during a blazing July evening and bullied it into freezing through superior architecture. Not quite. In many desert regions, winter nights can approach or fall below freezing. Yakhchāls harvested those hours, then preserved the result for the hot season. Still impressive, just less wizard adjacent. But here's the stranger part. The air itself did not always need to be below zero. A study of natural Iranian ice makers found that, under favorable humidity and wind conditions, ice could form when the surrounding air was about 4 degrees Celsius. That sounds wrong. Your refrigerator would file a complaint. So where did the extra cold come from? Look up. Everything warm emits infrared radiation. On a dry, cloudless night, some of the heat leaving a shallow pool can pass through the atmosphere toward the much colder sky. The pool may radiate energy away faster than the surrounding air returns it. Its surface can therefore fall below the air temperature. The same basic effect can leave frost on your car even when the official air temperature stayed slightly above freezing. Dry air also encourages evaporation. The fastest water molecules escape, carrying energy with them and cooling what remains. But radiation to the night sky appears to have done much of the crucial work at Yakhchāl basins. No moving parts, just a pond quietly losing an argument with space. How could ancient builders possibly know that? They didn't need equations. They needed repetition. Clear night, more ice. Cloudy night, less. Deep water, disappointing. Thin water, better. Sun on the basin, disaster. Put up a wall. Human beings can engineer a system long before anyone names the physics underneath it. Workers repeated the process over multiple nights. One shallow layer froze, then another layer was poured over it. Encyclopedia Iranica describes the ice building to roughly 50 centimeters before workers chopped it into blocks and carried it into the storage pit. Imagine tending a municipal freezer, one thin puddle at a time. And the job wasn't over. Inside the Yakhchāl, thick earthen walls slowed the movement of heat. The chamber sat below ground and out of direct sunlight. Ice blocks were packed together, reducing the amount of exposed surface compared with their total volume. Straw, reeds, and earth could add insulation. Some ice still melted. That was expected. The important detail was getting the meltwater away. Liquid water pressing against ice transfers heat efficiently, so drains or sumps carried it toward the lowest point. The machine succeeded partly because it was designed to lose ice gracefully. The larger mass also protected itself. Melting ice takes a surprising amount of energy, 344 kilojoules for every kilogram, what physicists call the latent heat of fusion. Heat could creep through the walls all day and spend itself melting the outer portion, while the center remained frozen. A little ice died, so the rest could make it to beverage season. Now, meet William Charles Wells. Wells was a physician and fellow of the Royal Society who published an essay on dew in 1814. His experiments helped explain why objects exposed to a clear sky could become colder than the air around them. The Royal Society awarded him the Rumford Medal for that work. More than 2,000 years after early Persian ice pits, credentialed European science finally supplied the plot diagram. Wells wasn't studying Yakhchāls, but his work supports a wonderfully wild idea. Ancient builders had constructed machines that used the sky itself as a heat sink. They weren't merely hiding winter underground. They were plugging shallow ponds into the cold above the atmosphere. That should have received better marketing. Except, here's where it gets complicated. Radiative cooling is real, but it doesn't turn every desert night into an ice factory. Clouds send infrared energy back downward. Humidity interferes with heat escaping through the atmosphere. Wind can bring warmer air across the pool. Water depth matters, location matters, and the historical descriptions specifically emphasize frosty winter months. The boring explanation is therefore the reliable one. Cold winter weather did most of the setup, while shallow water, shade, dry air, evaporation, and radiation made freezing more efficient. Then insulation, earth, drainage, and sheer volume slowed the summer melt. It was not one miracle. It was 10 small advantages standing on one another's shoulders. And Persia wasn't alone. Zhou-era China had officials assigned to collect and store winter ice. Texts describe ice sellers serving the royal court. In Mesopotamia, King Zimri Lim ordered an ice house built near Mari in the 18th century BCE. Across hot regions, ice required organized labor, storage, transport, and power. A cold drink was infrastructure you could sip. So what did ancient desert ice actually taste like? Probably expensive. Iranian ice houses mainly held solid ice for distribution during summer, not every imaginable food like a modern walk-in refrigerator. Courts, wealthy households, and paying customers had the easiest access. If someone handed you a chilled drink under a desert sun, you weren't just tasting water. You were tasting canals, masonry, night shifts, and several months of successful heat management. But one piece still refuses to freeze into place. Archaeologists and historians can describe surviving structures and later practices, yet the path from a simple insulated pit to the monumental domed Yakhchāl is poorly documented. The oldest traditions left fewer records than the younger buildings. We know the physics works. We know the ice houses worked. We don't know exactly who assembled every piece first or when. It's probably a story of winter cold, careful observation, and generations of practical improvements. But maybe that is the unsettling part. Someone, on some clear night, noticed that a shallow pool could become colder than the air and decided the sky was useful equipment. By summer, the desert was burning again, and winter was waiting underground. If you enjoyed that, watch our last investigation,
How did people cut their nails before clippers? Then leave the question you'd like answered next in the comments. Apparently, civilization is just a long list of chores nobody explained.